Today we're going to look at still doing bivariate data. So we've got the two lists and those pieces of information come from the one source. So if you look down here at our example here, the birth rate per 1,000 and the life expectancy, this was for 10 countries. So you can see that this piece of information is from one country. So a country that has 30 births per 1,000 people have a life expectancy of reaching 66 years. So that's the average life expectancy. So you can see that's what bivariate is. You're getting two pieces of information from the one data source. So the data meaning the country. So then you've got the 10 countries. So we're looking at that. Now today we're going to look at predictions. So predictions is when you use the linear regression equation, which you have been doing with your previously. So we're going to use that equation. So that's that equation where we've got y equals a plus bx. So we've been working out how to get that equation. If you remember, we're going to put our lists we'd put our lists in the calculator. So in lists and spreadsheets. And then, so we'd have that, and then we might have birth rate and life expectancy, blah, 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 blah. And then we do the menu, stat calculations and all that. And we end up finding what A equals and B equals so that we can write that equation out. So now we can use that equation and we could ask you, can you predict what might happen? Okay, so we've got this equation and we're going to make some predictions. Okay, so if I said, so with the birth rate per 1,000 and the life expectancy, the equations probably, the life expectancy will be the response variable and the birth rate would be the explanatory. So you would see a formula that predicts life expectancy or whatever. So we'd have A plus whatever we find B is times the birth rate. So if I said, all right, what happened if a country had a birth rate of 39, you would then go pop 39 into this formula, and where you see birth rate, you write times 39, and you'd work out the life expectancy. Okay, so that's a prediction when you use your equation to predict. Now, if you predict, if you predict within the range, it's called interpolation. Within the range, it means, can you see that the lowest birth rate here is 30, if you have a look there. So we've got the lowest one is 30, and then the highest one is, I think, 43, maybe, yeah? So if you're predicting, so if you were predicting a birth, if I asked you for a country with a birth rate between any number between 30 and 43, that would be interpolation. Okay, if I ask you to predict outside the, it's called extrapolation. So that would be if I'm asking you to do one that's, 30 or less, yeah, under 30, that would be extrapolating because it's not within what we've seen, or 43 and above. So if you ask with a number, so if I said predict the life expectancy of someone that had a birth rate of, say, 48, that means it's extrapolating. So why do we need to know this? This is because when we've gone and got all this data, really we only can see really what's happening between 30 and 43. You don't know, there could be some dramatic change outside where we've tested. So even though you're asked to predict, it's important to say, well, this is an extrapolation because it's not that reliable. We haven't really seen or had tested countries with that data. Okay, so if you see there, it says if you predict outside, it's the prediction is, sorry, that's missing a word there, is not reliable, it should be. It's not reliable. If you predict within the range, that is a reliable result. All right, so you might get asked that question later on. So let's go have a look at the next bit. So they've worked out the formula, and here, as I said, there's the life expectancy, and we said that. So on the calculator, when you put the lists in, that was your A value there, and this was your B value. Is that a negative direction or a positive direction, this graph? I can tell from that thing. How do I know? What is it? It's a negative. See, because the gradient's negative, so you know that the dots must be going down like that, yeah? It's a negative gradient, so that's a negative direction. So it says, what is the life expectancy of a country with the rate of 35? So you can see we popped that into the formula, and we put 35 there, and we found that it was 55 years. So just underneath, they've just written it out in words. You only have to write it out in words if they ask you. Most of the time, if they said what's the life expectancy, just write the little calculation and write 55. What is the life expectancy of a birth rate in the 70? So we work it out. So if you have 70 births per 1,000, it ends up being your life expectancy is 4.6 years. Now, does that sound realistic? No. So can you see when we tested outside an extreme range, something went wrong? Probably you wouldn't have that. Maybe that's just ridiculous to have that many births per 1,000 that quickly. But you generally see more births, the life expectancy would go down because you've got bigger drain on resources. All right, I'll just go to the next bit. Okay, so the other thing we need to do now is we might get asked to interpret the slope. So the slope, if you see there, is the B value. So before we had that formula, life expectancy equals, we had 105 or something minus 1.44 times birth rate. Okay, just going to put that one there. Okay, so if they ask you to interpret the slope, anytime you get asked an interpret question, means you're going to have to write something. I guarantee in your notes, you will have a fill in the blanks, okay? So I've made it so that you just have to put in the data and you write these exact words. And you can do this in year 12, so you don't have to stress. And you always have your reference book, so you've got it. So if we were doing our example that we've got here, if I had to interpret this slope, I'd look at the B value and I'd see that it is a -1, okay? So that means I'm going to use this little blurb, which you've got in your book. So if I asked to interpret it, I need to write this out. So I'd say now in my example, what's the response variable? Remember, that's the Y. Good. So I'll write the life expectancy decreases by, what's the actual number B is? What's B? What's the B in that equation? The slope. What's the gradient? Up in my example here. Which one's B? Yeah, 1.44. Good. No, that's the word decreases makes that, okay? You can put it on the side if you want. Okay, so the life expectancy decreases by 1.44 when and what's the EV? Yep, good. Birth rate increases by 1. And you can just say 1. It says units, but when it's a birth, there you go, 1 birth, that's fine. So that would be how you interpret that one. So there's both options there. So in case the B value was a positive, you'd use that top one. Now, if they ask you to interpret, so you'll see that word interpret. Once you know you see the word interpret, I will have a fill in the blanks in your book. You can guarantee it. Okay, so if they ask me to interpret the A value or the intercept, you'd have to write this thing. So I'd say, I'd write the regression line intercept, I'm just shorthanding here, predicts the RV, so the life expectancy, to be 105, because that's what the A value, when the EV is birth rate, so birth rate is 0. So if a country had no births, decided no more reproducing, they're predicting that they'd live to 105, most likely. Okay. All right. So I think I've written them out down the bottom anyway in your notes down here. So you've got them answers there. So that's what you're going to get. So today we're going to be practicing doing all of those things, interpolation and extrapolation.